Hi, everyone. Thanks for coming back again. This is Ken Shoulders number 59, and this is a really good one. It's actually about a drone, a toy that probably uses charge cluster technology to fly. And it was something that Ken Shoulders had actually done with his son, Steve Shoulders. And on that note, I have a little bit of information about that. I actually have Steve Shoulders' contact information, and I did reach out to him to kind of show him what we're up to, honoring his father and him and everyone, essentially. Now, he didn't get back to me, but I do know that he watched some of the stuff that I sent him because I can see things in real time on my YouTube channel. So, yeah, it's kind of cool. Uh, So, Chip, if you don't mind, we can start reading.
We'll go ahead. It's titled Shadow, a Unique Flying Entity by Ken Shoulders. There's a summary paragraph here. This writing concerns a new generation of miniature autonomous flying devices. Ken Shoulders established the basic concept over 30 years ago in a series of working prototypes done as a hobby. Vehicle is a disc-shaped ducted fan having highly controllable contra-rotating impellers powered by a specially designed internal combustion engine. Vehicle is outfitted with numerous sensors, giving it such a high degree of autonomous flight that intelligence is assigned to it by those watching its performance. Here's a preamble, the next paragraph. No inexpensive flying machine capable of sensible, independent action has yet been produced, which has captured the world's imagination and markets. This writing concerns just such an invention. It is a machine that is attracted to people, that is delightfully playful and has the elements of being capricious. It is capable of agile flight, yet still safe to those around it. It can be called upon and directed to do many complicated lifelike tasks. It can be summoned to play games, or if told to wait at a particular spot, it will do so until its fuel is exhausted. When it is in a crowd of people or objects, it knows who its master is, and like their shadow, will obediently follow them above their heads, out of reach of others if necessary. When alone, it will come down and be its master's companion.
Wow.
Generally, fads are rare and thought to be impossible to predict. But given the characteristics available in this class of entity, I am predicting one. Shadow is the kind of device that has the allure of video games, but is based on far more interesting and real physical action. It has all the ingredients needed to start a worldwide fad. And this is a picture of Steve Shoulders here, I presume.
Yep.
Here's a technical description in the next paragraph. Technically, the machine is a ducted fan class vertical takeoff and landing rotorcraft using vectored thrust for control. The overall appearance is shown in figure 1 and 2 as that of a flying saucer. The configuration is shown as an updated version of an older design with extreme emphasis placed on safety while making the necessary trade-off with efficiency. A very large percentage of the total thrust is useful for control by employing high-speed, pneumatically powered vane actuators embedded in the impeller that is housed in the duct. Two of these control vanes, located on the tips of a contra-rotating test rig, are shown in figure 3, while figure 4 shows several earlier test vanes. Each of the rotors or impellers have 12 blades on them. The control method gives Shadow a 3G maneuvering capability, rendering it almost impossible to catch by an unaided human. Jesus, a lot packed into that thing. Series of pictures, figure 3, 4 referred to already. A couple of additional ones. Pneumatically operated contra-rotating vanes, older versions of pillar vanes. It shows some of the preliminary designs. Those vanes are electrically controlled or monitored. Figures 5 and 6 further down on the page are pictures of the Molded parts, the structure of the craft, and the inlet vanes. Very good. Figure 5 shows the internal molded parts of test structures, while Figure 6 shows the top view of the inlet vanes. The engine operates as a two-stroke sleeve valve uniflow scavenged spark ignition internal combustion engine fueled by liquid petroleum gas, LPG. This combination greatly facilitates remote starting, lowers the noise, and removes odor and oil emissions. A drawing of the engine layout shown in Figure 7 and a photo of a test unit designed to measure valve timing and lubrication effects, along with combustion and cooling properties, is shown in Figure 8. All right, as shown in Figure 7, the engine has two cylinders, one of them acting as a power cylinder, the other acting as an air compressor. The air power produced by the compressor both charges the power cylinder and provides pneumatic power for operating the impeller vanes and fuel metering functions. Jesus, it's got a supercharger built. Another feature of the design is that the piston, sleeve valve, and cylinder are easily fabricated from ceramic.
Wow.
This construction technique has been tested on rotor air bearings and impeller vane commutators, found to be very amenable to small engine use. The range of power output over which the design function well is from 10 watts to 100 watts of power output, I presume. All right, here's Figure 8 showing a schematic photo of the experimental sleeve valve engine parts. Wow. All right, Shadow carries with it an ultrasonic sound source and appropriate detectors to regulate the vehicle height and sense nearby obstacles, avoiding them from vectoring the thrust away from the object when it is too close. The vehicle body is stabilized in the plane of flight by a combination of ultrasonic sensing, earth field magnetic detection, and airspeed detection. Applying differential torque to the impeller discs controls the heading of the body. When using sonic sensing, there are two competing functions in the control of the vehicle. First to be attracted to the object, from a distance, and then this function is overridden by a repel function to maintain an equilibrium distance from the object and to lock it there. Both the standoff distance and the height are continuously adjustable functions with limits of about 2 feet at the closest approach to a maximum of 20 feet from the object or ground. Next paragraph. Although no skill is required to operate the vehicle in the most basic modes, either a radio or ultrasonic link can be used to create higher modes of operation. Control distance is typical of low power radio channels, being several thousand feet for a small hand operated controller. An automatic homing function prevents the vehicle from getting out of range. The repel and attract channels in the control system are offset tuned from the vehicle ultrasonic source so that Doppler shifts are effective in giving the vehicle more interesting responses. If the repel channel is tuned higher than the sound source frequency, then the objects moving toward the machine are sensed more quickly or at a greater distance, and the machine will run from them. On the other hand, the vehicle chases objects that recede rapidly, and the standoff distance will be reduced. When the vehicle is required to fly through congested space, such as wooded areas, it strives to maintain the last heading, altitude, and speed command. In the event of complications, the vehicle alters the input commands and performs needed maneuvers to continue to the test area. It is functions like these that give it the appearance of being somewhat intelligent. Basic functions produced by the control system. Series of bullets. Altitude, number 1 bullet. Altitude regulation by ultrasonic sensing is used to maintain a prescribed height above any surface or cluster of obstacles. Overhead distance from objects is also leveraged, just like an ice maker. An ultrasonic anti-collision technique is used, resulting in the avoidance of obstacles above a certain minimum size. Number three, well, attraction to objects that are near the vertical horizontal plane, the vehicle horizontal plane, is combined with the repulsion characteristics of the anti-collision system to produce a standoff distance that has an automatic yet controllable parameter of the vehicle. Number four, variation of standoff distance depends on the movement of the object relative to the vehicle, being closer for a receding target than for an advancing target. Number five, control of vehicle heading and airspeed or ground speed is based on azimuthal air pressure detection and Doppler ultrasonic detection relative to the Earth magnetic field vector. Number six, gyroscopic damping signals are available arising from spinning impellers. Number seven, barometric height and rate controls are used when operated out of ultrasonic target range. Number eight, an automatic landing maneuver capability is available that is either under operator control or upon low fuel warning. Number nine, automatic homing occurs in the case of either low fuel or low signal strength from controlling transmitter. Number 10, GPS guidance and positioning is used for basic navigation. 11, Doppler sonic navigation and ground speed tracking is used for long-range flights when GPS signal fails. Number 12, remote engine start and shutdown, as well as idle condition, is available for landed operations, such as TV viewing, needing electrical power from the alternator. These basic characteristics, achieved in an integrated system of great physical simplicity, are the subject of U.S. patent number 3915414, issued to the author in 1975, 51 years. Using the modern electronic technology, the cost burden of achieving very complicated functions in autonomous flight vehicles operating with variations in the system described is minimal. General specifications for the Shadow: diameter 7 inches, thickness 3 inches, weight 6 ounces. Jeez, amazing. Engine type 2-stroke, 0.05 cubic inch through flow scavenged fuel injection, liquid petroleum gas. Maximum flight duration about 40 minutes. Speed 60 miles an hour max. Anti-collision distance max 40 feet. Minimum standoff 2 feet. Maximum 20 feet. Minimum height above the ground 2 feet under ultrasonic control. Maximum height above the ground 30 feet under ultrasonic control. Nominal control distance 1 mile without using an aerial platform relay station. Where can I buy one of these?
Yeah, have to ask Steve.
Games, the possibilities. The market potential of this product can be appreciated by examining the world of possibilities it opens up for new games. The game's functions produced are interesting, and the vehicle's response to dynamic situations in which players vie for the attention of Shadow by their body movements is almost beyond imagination. It is possible to steal Shadow from another person by executing a complex moving, causing Shadow to follow the fastest moving nearby target that came from the proper direction and then moved away from the original player in a particular direction. This action is affected by the ultrasonic sensing system without using any external control. When radio control is brought into play, games take on far greater complexity. The vertical height sensor beam is usually about 90 degrees wide, will not normally interfere with the lateral obstacle sensors, but when an object comes into the beam, the vehicle will rise over it. For example, when Shadow is hovering 5 feet above the ground, the lateral detection distance for an object to affect the height channel would be about 5 feet also. Small objects like a single player would have less effect on the height of Shadow than would a group. Shadow would treat a group of persons arranged around it as if they were ground and would rise above them. If a playing field, yard, or street were arranged to have goals at an arbitrary spot and the players divided into teams, the aim of one game would be to get Shadow to follow you to a goal area, while the competition would try to prevent it from luring Shadow to them by either individual or collective actions such as shielding Shadow from capture. Obviously, shielding must not be carried too far. A Shadow will rise up and fly over the captors and reattach to some target outside of the shielding area. Typical flight speed for Shadow under these conditions would be about 30 or 40 miles an hour, depending on safety requirements, making capture by physical means very difficult. This type of game can be played without using radio control of the vehicle. Flight duration would normally be about 40 minutes, thus giving ample time for various strategies to develop. Flying could be done either during the day or at night using alternator power for lights. If an individual had no one to compete with, he could go out with Shadow, do a great many novel and fun things. For example, if Shadow were repelled with a control source toward a wall or other objects such as a hedgerow, it would effectively bounce from the wall by acoustically sensing it and reversing course when the repelling sound source is stopped. The return course would resemble that of a bouncing ball, except that it would never physically strike anything. Body control of the vehicle without the use of radio commands would result in an interesting form of handball with the speed of response adjustable at will up to a limit of 60 miles an hour. The remote control could still be used to retrieve lost balls without running after them. If the height channel is coupled to the repeller attract sound frequency, then Shadow would rise while it is being repelled and sink while it is being attracted. Or the reverse, giving interesting three-dimensional games for single or multiple players. A backyard game of aerial croquet could be devised by assigning various obstacles to engage in prescribed ways, involving many skills such as a dynamic controllable ball as Shadow represents. Combat between multiple vehicles is a distinct possibility in which the ultrasonic beams aboard the vehicles are used as weapons and can be made to impact on another vehicle sensor in such a way that the target is deactivated when hit appropriately. For the less energetic players, a simple electronic dog walk might suffice. Or simply yet, sitting on a porch or remotely and annoying local bugs and other targets if of opportunity. It has often been noted in the past that flies and bees are strangely attracted to operating vehicles, and the inevitable outcome is for the machine to win, resulting in a messy streak of wipe off the surfaces. For very sedentary players, observing the response of Shadow to natural disturbances like the wind would be pleasant. Safety, subsection. The need for safety is important. Yeah, if it goes as fast as it does. The most striking difference between early works done by the author on vehicles having independent flight capabilities and the present work is in the degree of safety designed into the machine. There have been large trade-offs made in efficiency to achieve safety while at the same time, on the next page, while at the same time keeping cost and weight low and the flight duration long. No one would mind very much if a friendly, fuzzy little blue globe followed them around to do their bidding. But there's something sinister about an airborne switchblade spinning at high speed. A deducted fan configuration is an acceptable companion from a safety standpoint, but they don't work as well as a switchblade when it comes to the parameters needed for efficient, highly controlled flight. In our present design, we have managed to overcome that hurdle to an acceptable degree. In addition, a soft structure is used for most of the parts coming into contact with players. And thus, this gives Shadow no more hazardous features than those found in everyday living. Annoyance factors, next paragraph. Noisemakers invariably like the noise they make, while other listeners most often object to the noise. Miniature aircraft have acquired bad reputation for being noisemakers, when it seemed to have been done on purpose because it's hard to design them to be noisier. The largest, most easily corrected noise source is the engine exhaust. The second noisiest device is the high-speed propeller. Finally, the mechanical noises radiating from the engine are the least noisy, but still remarkably large. In the past, we have silenced small engines with lightweight and unobtrusive mufflers, so the noise is barely detectable 30 feet away, in a reasonably quiet rural background. In a typical urban area, the noise is masked up to a distance of 10 feet. We have given up on non-shrouded high-speed propellers for safety and noise reasons and found the noise from properly shrouded ducted propellers can be made very low. There is a compromise with good efficiency here, but one that must be made. The engine is totally enclosed in their design, and mechanical noise is expressed by the damping of plastic structures. Noise is largely a function of weight and efficiency, and therefore the horsepower used in the device. Shadow is thus inherently quieter than a machine designed for lifting heavy loads. In addition, we have plans to incorporate a much quieter type of engine never before used in a miniature aircraft. There is certainly the annoyance of a group of happy people shouting and playing, but we cannot design against that and still achieve our goal of selling Shadow to everyone as any vitality at all. Convenience. Next paragraph. Convenience must be built in like it never has been before. Almost everyone who's had experience with a model engine knows that it can be cantankerous, that they can be cantankerous beasts. And it is our first goal to dispel the fear that you have to be a specialist to run one. Most engines fail to start because either they have a rundown booster battery, fuel line plugged with hard to dissolve lubricant residue from evaporated fuel, that hand cranking requires too much skill, or that the needle valve adjustment is incorrect. Next paragraph. To offset these problems, it is necessary to begin again with small engine design, essentially make an engine act like an electric motor. To do this, we intend to use a uniflow scavenge configuration, having only light lubrication in the crankcase instead of mixing with the fuel. We intend to use an easily vaporized fuel like butane propane to remove temperature sensitivity. The fuel flow will be regulated automatically as an injection through a special injection ignition plug of our own device, giving engine speed regulation by the control system, thus removing the adjustment problem. The starting cycle is totally controlled by onboard sensors and only needs to be remotely turned on, off, or set to idle. These conveniences are obtained at increased cost, but not greatly so. In the operation of older vehicles, we have consistently used small alternators to supply the electrical power required because batteries are a source of sales resistance and difficulty. The initial cost of the alternator is less than that of rechargeable batteries and quickly adds up to a monetary asset during the life of Shadow. But most of all, the alternator keeps Shadow from getting a bad name as a battery user, minimizing inconvenience. Next paragraph. It is an inconvenience to put fuel in the vehicle, but this cannot be avoided. Electric flight would be nice, but there's presently no way to do it. We can at least make process of refueling better by selling fuel cartridges that simply insert in the filler cap without having to open and close various cans or transfer devices.
See. It's page 7. Right.
Yeah. Okay, it is a vast inconvenience to have the oil droplets from a mixed fuel two-stroke engine exhaust pipe sling out on your clothing and clean walls or windows of the house in which or on the surface of the swimming pool. By careful design and operation, these droplets can be caught in a section of the exhaust muffler and retained during flight to be drained later at the end of the flight. But this does not work for the average user. A separate lubrication in the crankcase has to be used. And this can be easily done with an engine design proposed here. It is also disagreeable to smell the funky exhaust products of a miniature engine. The solution is to burn gaseous fuels through disassociation unit, a unit like the one proposed here, in the injector igniter based on electron cluster technology. Here we go.
Bingo.
Yeah, let me reread that. The solution to this is to burn gaseous fuels through a disassociation unit like the one proposed here in the injector igniter based on electron cluster technology. This is an area that's very new and presumably very amenable to a strong patent position. If there's any remaining odor at all, it can be made pleasant by an additive that causes people to come from miles around to play with you. Perhaps the odors of frying bacon, coffee, or orange blossoms, depending on the type of person you want to play with. Such control over exhaust products gives Shadow distinct indoor flight possibilities. Lovability. Which man has a sense of humor? All right, lovability is designed into the shape and feel of Shadow, like being saucer-like. It is small enough in size to almost put in your pocket, although much of it sticks out. It has a good feel and weight distribution that affects people like a baseball glove affects players of that game. It has to be made into something that's compact and ever ready to go with you, even as for just a couple of quick passes at the wall, just a ball or and as just as a ball or glove are. We have designs that will come as close to this goal as is economically allowable at this time. The intrinsic limits of lovability for this class of machine are somewhat beyond where we are now, and they're primarily set by the power plant limits. As we go further into the field, we can afford the development of small, efficient, lightweight, and low-cost engines. We'll be able to package them into neat, compact vehicle designs that will capture the fancy of nearly anything lover. Pricing. Last paragraph here, next paragraph. Experience shows that the quality products can create their own market and command a relatively high price. In the toy field, the consumer typically pays 5 times the manufacturing cost, but this average includes the vast majority of products that have low customer evaluation. Fashionable designer products have a much higher price to utility ratio. Manufacturing rates of more than 300,000 units a year would allow a selling price for Shadow of $50. But the initial absence of competition would but in the initial absence of competition, it would not be unreasonable to base the price on the value instead of cost and sell the units in the range $100 to $200. Sale of fuel is a very attractive market, can be made a captive when using patented connectors, trade names, and warning signs on Shadow. Sales would probably be to a market that does not want to experiment, will stick to the manufacturer's recommendations. Market structure, next paragraph. Market segments for Shadow include a highly competitive age group for boys between 8 and 25 years old. Girl participation factors unknown at this time. The group game appeal would be optimized here, but still giving good performance with a single player that wanted to practice. Another segment would be older men and women who wanted to keep in shape without going to specially prepared gyms or jogging areas. It would be necessary to make Shadow highly maneuverable so the fast game of singles handball could be played in the backyard without a specially prepared site. Pickle Shadow. There you go.
Mm-hmm.
Various rules and games would serve to keep things interesting. These machines would need higher reliability and be more expensive than the ones sold for a lower age group. Segment that is close to the exercise model is the competition class of machine, where the appeal of final playoffs between regions demands higher quality and a sales outlet through sporting goods stores. The machine for creative little people offers another segment whereby the machine can be programmed and masked to do a wide variety of different things. Such card programming techniques add only slightly to the cost. Cross-coupling of the various functions would be very instructive, and since the possibility of damaging Shadow is always there, the participant is up against a real adversary. The price of this device is also somewhat higher than the cheapest toy. All right, final page. It is obvious that the kit segment of the market is available where the price is lower by a small amount, but the appeal of construction is the main thing sought. Servicing paragraph. Servicing of such a technical product is necessary, but it should be done in such the same fashion as race cars and other technical products by exchange of sub-assemblies. The cost and time delay of sending Shadow to service centers are prohibitive to the customer, and such stations are very difficult for the manufacturer to establish quickly. The package merchandising technique is very good for selling parts and sub-assemblies and used throughout the model industry. The main units of Shadow would be the power unit, impeller wheel and actuators, mainframe, sensors, and electronic control unit. The replacement costs of the power unit and mainframe are the highest, and if necessary, it can be broken down into lesser units during design to get comparable costs for all units. The selling price for the total of all the subassemblies would typically 2 or 3 times the price of the completely assembled unit. By using the servicing technique, it is possible to lower the setup costs of a servicing organization, but it would be necessary to increase the cost of development and possibly to raise the initial cost of the unit, although some manufacturing simplifications result from the modular construction, thus partly offsetting this cost. Propagating structure. The propagating structure that creates the shadow market must have at least minimal engineering capability in electronic controls, sonic sensors, aerodynamics, and power plants. The product design aspects should be done through several iterations, interspersed with customer acceptance tests. Initial manufacturing can be done on a small lot basis, either in-house or by assembly of jobbed-out parts. Ultimately, high production manufacturing will require either the generation of new plant facilities or the merger with and purchase of an existing company capable of engine manufacture. Shadow seems to fall in between the hobby and the toy field, but marketing channels for toys would seem to suffice. Last paragraph, the future. Future is wide open once a controllable device of this type is successfully introduced. Increased long-range control capability for directing shadow to any desired spot within a modest range of a few miles is the next most obvious move. After that, units to perform autonomous, complex functions at great distance are possible. Scaled up versions of the same system would produce TV platforms, messenger machines, industrial pack vehicles, sport devices capable of lifting a man. Further down the line, after the necessary degree of reliability has been attained, personal air transportation can become a reality.
Wow, right? Interesting. Thanks, Chip. Yeah, so
Maybe
pretty
lithium
cool.
batteries would work these days.
Yeah, and where do we, like you said, where do we get one of these?
It'd be
Yesterday, I want one yesterday.
be
Exactly.
interesting to interview Steve and see how far they got with the actual prototypes that they actually built. That's amazing.
Yeah,
It's amazing that right he's focused there, right? Whereas he made the discovery of the charge clusters, and he mentions it. So
yeah.
he had the discovery at that point, which of course charge clusters wide open for research 20 years prior to the 1991 patent on charge clusters themselves and all the mysteries, right, and et cetera. So it'd be very interesting to hear the story from Steve, right? So he's a little boy at the time uh, Ken starting with this project.
Yeah, like
Yeah,
1975,
it's
right?
yeah to do what he described in that patent back then. There's
Yeah.
hardly had any computers, right,
No.
at all, right? It's well, it's amazing. Or the alternative was Ken had a great imagination and just loved the concept of flight. Propulsion was his goal. And when he discovered the EVOs, that by the way, that was named by Steve because Ken had
Oh,
EVs.
I
Yeah,
didn't know that. Okay.
that was the history of that name change. And he says that's because he wasn't ready to uh, commit to their interacting with the vacuum energy. He didn't know. He just the discovery originally was when he was working with Bostic on the plasmoid research. He worked with Bostic, and that's where he first observed, and there's plasmoid discharges. The other side, these tiny little EVOs, and Bostic was interested in the big plasmoids, and he was interested in what's going on the back end. So he took that. So he knew they existed, right, from that original research that he did, perhaps in the 60s. So it would be fun if Steve gave us a history of, wow, Of course, as you can see, he had a huge imagination, so he could easily have written that patent straight out of his mind, right? And knowing what the technology available at that time was to basically construct the patents. So it's not clear they actually built what they built.
Yeah.
And so it'd be fun to hear what they built. What
Yeah.
Because I
Yeah.
mean I mean that to do it back then, right? Build what he described. Well, you can
Yeah.
just imagine the effort that it would take to
'Cause
actually do it.
all those features are just getting put into drones nowadays. Like
Yeah.
I
Exactly.
think the one that resembles that the most is called the Sky Dio. Of course, it's all CCD instead of using ultrasonic sensors. It's all CCD controlled, and it will follow
Yeah.
you around and do those things. But this is, how many years later?
Yeah,
Yeah.
and so he writes the patent. So it's issued in 75, right? That's the patent date. Typically takes 2 years. So he writes that patent in 73.
Yeah.
Yeah,
He had
that's a
it'd be
just
2 years before that. Yeah.
Yeah.
yeah. So that's amazing. So
And
to the question what they built, so Steve will have a hell of an interesting story on the history, I'm sure.
so if Steve, if you do get a chance to watch this, I will send it to you. Yeah, we'd love to hear from you or even have you in the group at some point. Definitely. And yeah, it's pretty amazing technology, right? He's Ken, well, Chris Beskar said it the best. He said the pillar of the foundation of science is Ken Shoulders' research and work in the future. So, and one thing that we do know from Stavati now is that the technology that Ken Shoulders worked with, the charge clusters, was used in classified programs by Stavati Aerospace. So that's something that we do know from Chris in interviews that I've done with him and stuff. So yeah, very, very interesting.
So if we just spitball as the igniter injection system, what is exactly happening here? I mean, is it like a Stan Myers motor with hydrogen nanobubbles? He's making nanobubbles of propane, an LPG substance that has a COP over one. It's clutching vacuum energy, nucleating around propane or butane, whatever the LPG is. And he didn't say anything in the description about, it's miles per gallon fuel economy, but it seems to be that same sparker igniter configuration. It creates these huge, highly potentiated nano entities, cavitation type entities that is driving his engine, and he just off the cuff mentions it. So he had to really kind of understand it in 1975 before he did all the micrographs and Shaparanoff generator pictures and everything else.
Yeah.
He
And the
instinctively
funny
knew
thing
how it
is,
worked.
that was the same time that Paul had started subquantum kinetics around too, or started
Oh,
putting it
really?
together.
The
Yeah,
Oh my
concepts of it.
gosh.
Yeah.
73s. Yeah.
Yeah. Totally. So pretty cool
It's
stuff.
it's almost as if they didn't want to get shouted off the stage or embarrassed by the academic assholes that didn't fully grasp the vacuum aspect of anything in 1970. So he just kind of puts his toe in the water, says, I'm going to make a little toy here.
Yeah.
Yep.
And oh, by the way, it has an EVO engine at the heart.
Yep. So it's yeah, it's proof that he was onto something, way, way back when, essentially, right?
Now, what the claims would be interesting. Are the claims part of the document? The patent
Uh,
claim.
If
It'd
we
be
could see the
interesting
patent, yeah.
to look up the patent. Yeah, and have a look at the patent now.
yeah,
Let's
you know
do that,
what?
Ed. Yeah.
Yeah, I actually have all of the Ken Shoulders patents printed off that I got from Chris Beskar. I'll have to dig into my library and have a look at see if that one's actually in there or not. Yeah,
Because
pretty cool.
historically, his work on the EVs, he was and he was working with Puthoff in the 80s. So they kept it well under wraps. He did not want to advertise it. I personally had no idea. And then the patent comes out in 91. I don't even think I catch wind of it until somebody tells me, I think in 92, where I learn of Ken Shoulders and all the work. So I'm really late to the party, especially if he started back in the 70s. But he loved the UFO propulsion. He called it
Yeah.
propulsion. He didn't want to use UFO. He just said propulsion.
Propulsion.
And so
Yeah.
he loved flying saucers, and that was his vision. And he was a true genius. His history was he went to Texas A&M as a 16-year-old, and he
Oh, wow.
says
I didn't know that.
too early, way too early. I was not ready. He did some prank blowing up toilets in the dorm or something. He was thrown out. Enters in 2016, thrown out in 2017, and he immediately goes to work, right, in the engineering field. So he wrote all the patents himself. So if you read his 100 columns in the EV patent for the original EVs, is what he called them, electron volittum.
Yeah.
Uh, he wrote that all himself. So it's a beautiful read. He didn't write in legalese. He wrote in English.
Yeah.
And why did you write so much about it? He was trying to cover all applications that you could possibly do with this discovery, so that somebody couldn't write a wrapper patent that
Yep.
would block him. And that's what motivated him to just in his imagination come up with all the alternative possible things he could think of, so somebody else couldn't patent it and
Yeah.
block him. And that's why it got so big. I says, man, aren't you jumping the gun here? As I was reading, we barely understand what you discovered, and here you're going trying to apply it to a variety of things. And he really talked about how to harvest the energy, right? All the things he could think of
Yeah.
to.
And it
Go
was
ahead.
it was so he did two things. He wrote the book EVS, A Tale of Discovery, to kind of foil the patent office. And he built things like this that were put in the public domain, kind of, but really what he was doing was working with Stavati again back in the background, developing classified programs essentially, and no one knew about it until Chris Beskar kind of came to the public, and we brought them to the public and started talking about all this stuff, right? So it's really interesting, definitely.
And what year was he about? What time frame was he working on this classified work? Or in the 70s while he's writing this patent on this flying saucer?
Murray, that's a great question. I'm going to be interviewing Chris Beskar at some point again here in the future. That might be a really great question to ask him,
Yeah, if he
essentially.
says
When,
he worked with him, likewise the Pete Peterson question, but Pete was more unknown. He didn't do much other than just talk remarkable things. That's how I knew of Pete. He, in a way, at irony, he was kind of a joke, right? He would talk about these cuckoo things, and we just kind of chuckled, right? Oh, that's just
well,
Pete, right?
one thing I do know about Pete Peterson, and this comes from David Wilcock, who was his connection before even Stavati came along, essentially, was that well, I just forgot what I was going to say about David Wilcock there. Yeah, sorry, Pete Peterson.
The history of what's coming out of their minds. I see this
Oh,
pattern, a bizarre history. Oh,
yeah,
now
Yeah.
that you remember,
yeah.
Yeah.
this is what they're
S-
saying, and go, whoa, where'd that come from? It's like off in
so
some parallel dimension,
yeah,
Yeah.
so what it is David Wilcock, and I confirmed this because I went back to the recording and looked at it again. Pete Peterson was the grandson of Nikola Tesla's lab assistant. And that's why he ended up at Area 51, essentially, or one of the reasons why, essentially, right? So there's a lot of stuff about Pete Peterson that people just don't know or understand. And, even yourself knowing
or
him
believe, right?
or,
Or
or believe,
believe.
well, yeah,
Yeah.
that too,
He might be
exactly.
shooting his mouth off. I said, if you really were a classified program, you wouldn't do that, right? You wouldn't be. And so it's kind of bizarre because the information's bizarre.
Yeah,
And
but
so,
this all comes from, spending hours and hours and years, if not, talking with Chris Beskar about the whole situation and how it all came to be, because it was actually David Wilcock had an insider at Area 51, and this was before David Wilcock knew Chris Beskar. Uh, David's insider at Area 51 was Pete Peterson, basically, and one day David Wilcock and Pete kind of decided to introduce Chris Beskar to David Wilcock, and that's the whole story about how Stavati came to be. The story that we know now, essentially, that was not known, but we kind of brought them out to the public, starting about 5 years ago. I think is when I first started being in contact with David, and then eventually with Chris. February 8th of 2023 was the day that Chris actually texted me for the first time. Um,
um,
yeah,
when was Chris born, Chris Beskar?
he is 50 something. I think he's probably 52, if I'm not mistaken, or something like that. 53,
Right
something like.
now?
Yeah, I think so, because I know he's younger than I am a little bit. Yeah, yeah. So I'm not exactly sure. We could ask him again too, right? When he was born and stuff. But that was the whole thing. And Chris approached the Air Force at a remarkable age, in the eighth grade, in fact. And that's where all of the stuff sort of started happening for him. And I've got this on a clip, and it was in one of the interviews. Chris said by the age of 23, he had accomplished everything in life. Now, what does that actually mean? That means that by the age of 23, he was already working in classified programs, on all of this stuff, essentially, with Pete Peterson, I might add, and Ken Shoulders. Now, I don't know when Ken got involved with it all. We need to find out more information on that and ask Chris some more
Yeah.
questions, actually.
So
Yeah.
if he's in his 50s, we can just subtract right from now. So at the turn of the century, at 2000, he's age 25. So he's born 25 years earlier, 1975. And that's when Shoulders writes that patent, when Chris Beskard is born, right? So things don't really start happening if Chris is 25 to the year 2000, if there's going to
Well,
be any
Chris
interaction.
Chris was 13 when he first started interacting with military and DARPA. And by the age of 23, he had accomplished everything in life. So that in that decade between 13 and 23, is
So
basically.
he's 25 at the year 2000. So we just back up a few years,
40
right?
years ago. Yeah.
Yeah, to
1886.
the 90s, right? So if he's 75, so in 85 he turns 20. So he's 25 by 90, and a patent comes out in 91, right? On Ken Shoulders' work.
Yeah.
So we have basically a young teenager claiming he's working at that's his age. Uh,
Yep. Yeah, the eighth grade. He
and
he won
so
he won a drawing contest for the best fighter design, and soon after that, he was basically asked into these programs. That's his whole claim to fame, essentially, right?
Mm.
So, like I said, by the age of 23, he had accomplished everything in life.
There's
And I
like a
do
child,
know that from 94 to 2004, he worked in classified programs.
there's like a
He's told
child prodigy,
me that.
Eddie. He's a child prodigy, I think.
Oh, absolutely. Without a doubt, right?
It also
Absolute
rings
genius.
parallel to David Adair's claims, how he was taken at young teens by this general in the military. You know, just saying, it's. I see a lot of parallels with that, right?
Yeah. Yeah.
Similarities.
The military, when they see people of this caliber, they jump on it. And it was actually Chris that approached the Air Force, not the opposite way around, too. So because he won that drawing contest, they took notice. Chris Beskar is the equivalent of William Tompkins.
It's the
really.
same as William Tompkins because he was making the model ships and that too. So
Exactly. And the
At, at,
military
at what
approached
age?
him.
What age was he?
Tompkins was, oh, let's see here.
about 8 years old or so.
Yeah, and then eventually the military took notice because he was putting radar
Yeah.
information on these ships, and then these ships were in a window where people could walk by in the public. The military actually went to his house and they thought it was his father that was doing this, and they said, "No, it's not. It's my son." And at that point,
As an 8-year-old?
I don't, you know what? I'll have to check into that more, because I do know, and I do have all the information. It's all in his books, Selected by Extraterrestrials, and there's three versions or three editions out right now, but there is a fourth edition because I knew Dr. Robert Wood, who is the main editor of Tompkins' books. He used to call me on the phone, and
I think he
yeah,
was
so
in high school and they recruited him straight out of high school. He hadn't quite graduated yet.
William Tompkins, yeah.
I believe so. And his father, the deal was as long as he wouldn't have to fight on the front lines because it's during the war.
That's exactly right. Yeah. What was going on was there were these spies coming out of Germany, describing to James Forrestal, who was the Secretary of the Navy at the time, and also MJ3, and Admiral Ricoboto, William Tompkins, and a few others. These spies would come over from Germany, and they were talking about all these fantastic technologies, which basically use charge clusters. Now we know. And it was Tompkins as a teenager, yeah, you're right, who actually was brought into these programs. And then in 1952, he started the Rockwell Space Chart, which is the chemical rocket program that NASA is still using. And, we landed, or, Artemis came back. So I went to my Rockwell Space Chart that day and looked at it. And they're talking about Artemis 5 building a moon base. Now, I looked on the Rockwell Space Chart, and it looks like we're about 10 years behind. On the Rockwell Space Chart, the moon base is in about 2018, but in reality, the moon base is going to be about 2028 or thereabouts. So we're about 10 years behind. But the thing about William Tompkins is not only did he design the chemical rocket program that NASA's still using, and he was the section engineering chief of the command module that went to the moon. But he also designed the Solar Warden program, which is an anti-gravity program that the Navy ran, and for years until Space Force basically took it over, essentially. So that's kind of the story of William Tompkins.
Now, Space Force kind of teamed up with an extraterrestrial group. Like they say, the Dracos teamed up with the Nazis to get them way advanced.
Yeah,
So is there a
there,
team
there
for our
is.
secret space program that propels us way to be super advanced?
Yes,
Because
and
you have the
so
control system to steer how you steer the damn thing, right?
yeah, it's Solar Warden. Is the program that you're talking about, and Tompkins really started working on that in the 50s as well, at Douglas Aircraft Company, in the think tank. Now, thing about Dr. Robert Wood is Dr. Robert Wood actually also worked at Douglas, and he was there when Tompkins was there, and he was in think tanks because he told me that.
He
He
was
said,
in MJ12, wasn't he?
Would?
Wood?
no,
Wasn't he?
No,
No?
no,
I
no,
Oh.
don't think so.
no."
He was
So,
too nice of a guy.
yeah, so Robert Wood told me that I lost my train of thought a little bit there.
Sorry.
He um yeah, he worked, okay, so he worked at Douglas at the same time as Tompkins was there, and he was in secret think tanks, but he wasn't in the top tier secret think tank that Tompkins was in. And then when Tompkins came out to the public and started talking about it, because literally the Navy said, "You can talk about this. We want you to talk about everything," at the highest level of commands, then it all started to come out essentially. And that's kind of the whole story of Selected by Extraterrestrials. And then eventually, and David Wilcock knew William Tompkins as well. I never met him, but I do know of 6 people that knew him personally, including Dr. Robert Wood, David Wilcock, Dr. Sala, Jeff Rentz, Carrie Cassidy, and I'm probably missing someone else there too, but those are all the people that actually knew Tompkins. Oh, Frank Chili, of course, because Frank Chili was the actual guy that really brought Tompkins out to the public.
Let me ask a question, may lead to insight. Were these people likewise childhood geniuses? There's a pattern here. This is what I'm getting to. That
Mhm.
David
that
Wilcock.
just knew too much as prior, like under 10 years old. They're not even in puberty yet, and now they know way too much.
Yeah,
They're born
David
with it.
Wilcock.
And now here's the hypothesis. We have a bunch of children born like this with this information imprinted. It may be related to parallel lives or extraterrestrial
Well,
contact.
they're star seeds.
Yeah, star seeds, but
Very at the very least.
they
Yeah.
know too much, too
They
young.
could be
Right.
full-blown Pleiadian too. So
Right. So that's the clue. They know too much when they're too young. The military says, "Oh, let's take advantage of this information and round them up and get them to work for us," right? And then you could argue that, oh, don't try to keep this advanced stuff a secret. You can't really keep it a secret anyway, but just let them talk about it because it's so fantastic, like science fiction. Nobody's going to believe it's real.
Yep.
exactly.
Exactly. Yep.
Nobody's, and and what does that do? Oh, it attracts others that are
Yeah.
of like mind. Other children all of a sudden get attracted to the others. Military catches wind of them, and into the system they go to be providers of information.
You know,
One,
Moray,
one,
Which also impresses me that why they let's say John Hutchinson, who we know, why are they letting him go with all this bizarre stuff, and we can see the bizarre stuff working, right? And they want the information.
because the
About
reason for that is because there is a good part of the military and known as the White Hats, and the Navy who ran the Solar Warden program. That's who they were essentially. So there were different secret space programs. The Navy ran the Solar Warden program, which was the good one. The Nazis ran the Dark Fleet, which was basically the bad one. But there were others as
I just
well.
want to say, just to let you know, we're still recording. So,
Yeah.
yeah, could we? I'd like to get Ica back in if we
Yeah,
could.
so maybe we should shut the recording off.
we
And
should
then...
ask Ica. She'll have the answer.
Well, yeah.
Okay,
Yay!
cool.
okay, well,
Okay, well,
thank you, everyone. I hope you have a wonderful rest of the day. Cheers. Thanks for watching. Cheers. Bye.
bye.